In many horror films, there's a recurring theme involving a mirror image of a person that exists as a separate, malevolent entity. This evil twin in the mirror seeks to destroy its counterpart in the real world. Interestingly, our universe may have a similar evil twin, a mysterious mirror version of itself. The theory that hints at this possibility is known as CPT symmetry. CPT symmetry stands for charge, parity, and time. C stands for charge conjugation, which means that for every elementary particle, there's a twin with an opposite charge, like antineutrons, positrons, and other antiparticles. P refers to parity, which suggests that the directions in our three-dimensional space have opposites. Lastly, T stands for time symmetry, implying that alongside our forward flow of time, there's a symmetric flow in the opposite direction. Right after the Big Bang, matter and antimatter were equally divided, but as the universe evolved, only a small surplus of matter remained, forming the universe we observe today. Physicists have long pondered why this symmetry was broken and where all the antimatter vanished. If antimatter had survived in large quantities, the universe might have annihilated itself, as matter and antimatter annihilate each other upon contact, releasing massive amounts of energy. One hypothesis suggested that more matter existed than antimatter, leading to the universe's formation. But this theory was mathematically inconsistent. Enter Canadian scientists from the Perimeter Institute for Theoretical Physics, led by Neil Turok. They proposed a bold new idea. After the Big Bang, two universes formed. Our universe, composed of matter, and a mirror anti-universe composed entirely of antimatter. In this anti-universe, time flows in reverse from the future to the past. Imagine an antimatter version of you, sitting upside down in front of an inverted computer, knowing how everything in your life will unfold because it looks backward in time. This raises intriguing questions. What is life like in an antimatter universe? Can we ever make contact? To explore this, scientists have experimented with antiparticles since the 1930s. They've managed to create positrons, which are anti-electrons and antiprotons, and later, even whole anti-atoms like anti-helium and anti-hydrogen. However, studying them is extremely challenging because when antimatter meets matter, annihilation occurs, destroying both in an explosion of energy. Thanks to advances in technology, physicists developed electromagnetic traps to prevent particles and antiparticles from colliding immediately. In 2011, anti-hydrogen atoms survived for 1,000 seconds, and by 2014, scientists were able to create 80 anti-hydrogen atoms for more detailed study. However, despite these efforts, much about antimatter remains a mystery. But one thing is clear: if you somehow entered the anti-universe, you would be doomed. Your body, made of ordinary matter, would explode upon contact with antimatter, releasing enormous amounts of energy. In fact, the interaction of just 1 gram of antimatter with matter equals the explosive power of 21.5 kilotons, more than the bomb dropped on Nagasaki. The human body, weighing around 75 kilograms, would unleash the equivalent of over 76,000 Nagasaki bombs. The result would be catastrophic, either for you or for life in the anti-universe. Interestingly, small-scale antimatter interactions happen inside your body every hour. The radioactive isotope potassium-40, which enters your body through food and air, decays and emits positrons. This creates around 180 antiparticles every hour, or roughly 4,000 per day. These antiparticles annihilate immediately, releasing gamma radiation, a small but constant reminder of the antimatter in our world. If you could somehow extract antimatter safely, you could become fabulously wealthy. NASA estimated in 2006 that a milligram of positrons would cost about $25 million. And in 1999, a gram of antihydrogen was valued at $62.5 trillion. But instead of vast riches, you're more likely to meet a painful, explosive death. Another obstacle to reaching the anti-universe is time. The anti-universe would exist before the Big Bang, more than 14 billion years ago. Even if we could safely approach antimatter, we'd need to travel back in time. A feat that's theoretically possible within our universe, but not yet achievable. Some physicists even suggest we might already be living in the anti-universe, and our perception of time and matter would still seem normal, regardless of which side of the Big Bang we're on. Whether or not this is true, our universe and the anti-universe may influence each other. When scientists create or destroy particles, an antiparticle is born or dies in response, constantly maintaining this cosmic balance. While the idea of an anti-universe is mind-bending, recent research could challenge its existence. Scientists from Brookhaven National Laboratory and the University of Kansas proposed that the absence of antimatter in our universe could be due to the Higgs troika, three types of Higgs bosons, one of which is the God particle. These particles decay rapidly, producing streams of matter that could have wiped out most of the antimatter after the Big Bang. However, only one of the three Higgs bosons has been discovered, leaving room for the anti-universe theory to persist. So whether the anti-universe exists or not, the very thought of it turns our understanding of reality upside down. The possibility of a mirror copy of our world, with its own version of each of us, forces us to question everything we know about the universe.